the reason I wanted you on is because I think you can explain what's going on at a deeper level, and I appreciate the school lesson. Something that was really helpful to me to think about is that we think of eyes as vision centers that we see through, and they are that, but they're more than that. They are clocks that tell the time using light. And that if we are getting the wrong time signals from our environment at the wrong times of day, that's obviously going to lead to all of these issues that you talked about. The sleep being a huge one. If you're not sleeping well, you're not repairing well, you are not thriving at your highest potential. But another thing that gets really fascinating is we can't just leave this at the sleep thing, because it impacts everything else. You tell me how I may have even stole this analogy from you, so maybe I'm just regurgitating it back to you, but something along the lines of, you can put the best quality fuel in the machine. We highly suggest you do that, and something like an animal-based diet, earth-grown nutrients, clean, organic, good proteins, good fats, stable fats, all of that stuff. But if the fuel that's really good is coming in and the engine is broken, you're not going to go very far, right? If the pistons are cracked, if the spark plug isn't sparking, then the fuel can only take you so far. You're really looking at light here as an engine, a spark plug, and how that relates to the machinery really that runs the show, the mitochondria and energy production, because it's much more than sleep, right? This is why light diet is your term. This is malillumination, like malnutrition, right? Tell me a little bit more about how light regulates metabolism and energy.
Yeah, well, first of all, you nailed the analogy, so I don't think I have to restate it. It's perfect. There is this whole system in our body that is designed like a car engine, much more similarly than one might think on the surface, actually, to burn fuel. And what does a car engine do? Well, it burns fuel. It consumes hydrogen-based fuel in the form of gasoline or diesel, and it puts energy in, and that initial spark, which is, for example, in the case of the spark plugs, the battery, and then the spark plugs firing the pistons, that energy causes hydrogen to break off of its storage molecule, which would be carbon in the case of a hydrocarbon, or which is the same as sugar or fat. And then the hydrogens are free. And then hydrogens that are free, well, think about like a blimp filled with hydrogen. As soon as the hydrogen's exposed to oxygen, what happens? They bind. And when they bind, they release a lot of energy. They make water first, and they release a lot of energy as a result. And that's fire. So that energy is fire. And so basically, it's interesting, right? Water makes fire, and fire makes water. Sounds very spiritually profound when I put it that way. But in fact, it's true. So in the case of the car engine, the hydrogen on the hydrocarbon fuel, hydrogens are ripped off using the spark, the energy. They start binding with the oxygen, which is allowed into the engine in certain quantities. They make water. The water comes out the exhaust pipe as steam, which you don't even see, which is why we don't think that fires make water, but it is there. And then the ton of energy that's released is used to fire the pistons and cause things to move in ways that I don't fully understand, because I'm not an expert on car engines. But anyway, in the mitochondria, it is quite the same. We also consume hydrogen-based fuel in the form of carbohydrates or fats, and then we input energy from, well, in the process of, for example, the Krebs cycle, we input energy to break off the hydrogens, and then we input we break down the molecules, and then we get the simplest form, let's say NADH, which can then donate the hydrogens to the electron transport chain in the mitochondria. And then those hydrogens actually go into the inner membrane space, or inner mitochondrial space, which is the mitochondrial matrix, and the electrons from the hydrogen, which are the excited electrons, they run across this chain, the electron transport chain, and then that energy is used to pump the hydrogens across this membrane into this mitochondrial matrix. And it's basically just a system where life is using energy to kind of like push a bunch of balls like into one position, and then gravity will like pull them down and causing a turbine to spin. So it's like, dude, push all this stuff up and then go down through this turbine and make it spin. And in this case, The turbine is the ATPase. So packing a lot of hydrogen in the mitochondrial matrix causes the hydrogens, they're positively charged, so they push against each other. It causes them to go out of the ATPase, and it causes the ATPase to spin just like a turbine, and then that's used to make ATP, which is one of the energy currencies of biology for biochemical reactions and so on. But what's actually happening there at the end of the mitochondrial respiration process, it's called oxidative phosphorylation. So it's phosphorylating ATP using oxidation, and what's being oxidized is the food that we consume. But so anyway, then at the end, the hydrogen binds with oxygen. So oxygen, this is the reason we breathe. So we breathe in the oxygen, and that oxygen is being used to pull the electrons towards it because it has a very strong electronegative pull. And that energy is being siphoned out along that chain along the way with oxygen pulling it. Now, this is quite a detailed explanation, but it's important for people to understand, I think, why this is important and what's happening. So basically, and it is quite simple, in fact, if you look at it. It's just an internal fire, like Wim Hof talks about, but oxygen's pulling the electrons across the chain. I can explain how fascinating this is for me with one story, which is that when I was a freshman in high school in biology, I asked my biology teacher, I didn't call him bro, but Mr. Tudor, why do the electrons flow across the chain? Like, how do they know to go across the chain? And he's just like, they just do. And I was like, really? You can't explain it any better than that. And he obviously didn't understand it even at this level, unfortunately. Probably shouldn't have named him. Sorry, Mr. Tudor. But anyway,
We love you, Mr. Tudor.
That's how it is. So basically, the oxygen has this strong electronegativity, which is why it causes, bike chains to rust and these kind of things. It's quite a damaging molecule, in fact. And that's why life that managed, but it's also very powerful. Life that figured out how to master the use of oxygen is the life that took over the world. Melatonin is the antioxidant molecule that showed up around the same time that oxygen entered the atmosphere in significant quantities because of photosynthesis and the Cambrian explosion in this time period. And so melatonin is actually the antidote to oxygen, to oxidative damage that is caused as a result of oxygen production, or as a result of using oxygen to make energy. So let's bring this together a little bit more. So when you're making energy in the mitochondria with electrons flowing down the electron transport chain, inevitably the process isn't always perfectly efficient. And what happens is that there's metabolic smoke that's produced. And this is called reactive oxygen species, or free radicals. And these molecules are these sort of rogue agents that are going around trying to steal electrons from elsewhere. And the better our mitochondria work in general, the less free radicals we make. And the worse our mitochondria work, the more free radicals we make. And a lot of this is actually necessary for signaling. So like enough free radicals actually stimulate the process of new mitochondria, production of new mitochondria, because it's like, okay, the other ones are bad and old now. So melatonin, what it does is it actually scavenges these free radical molecules. So it's antioxidant. It's scavenging free radical molecules. But the idea, just making a note here that's relevant, the idea of like overdosing on antioxidants all the time is a little bit misguided, because you can also disrupt the very delicate system that's necessary, as I said before, for informing the body of what's going on and to make new mitochondria or not. So you don't want to OD on antioxidants. Better to fix the system so that you're not producing so much oxidative damage in the first place. How? Melatonin, which is produced with daylight exposure to sunlight in the day, especially in the morning, and then absence of light at night, or in other words, darkness, so that the melatonin can be secreted. So that's kind of high level. Just to try to wrap it together once more. So the key thing for people to really understand is when I'm breathing, like long, slow, deep nose inhales, which, it's hard when you're talking a bunch, but that's how, the best way to breathe is long, slow, deep nose inhales constantly. Keep your fire as consistent as possible. Really like keep it really balanced. This is why all the yogi stuff is fascinating to me, because all of this led to that. And if we have a few minutes, we could also touch on stuff like that if you'd like. But anyway, so basically, what we're doing with that oxygen is using it to pull electrons towards it. and generate energy and keep this system going in our mitochondria. So we're taking hydrogen-based fuel and oxygen from the air, we're burning them. We make water. Water is the end product of mitochondrial respiration, and the water hydrates our cells, and then the energy, the fire, is used again to pump those protons across the gradient. Some of it's released as heat. Depending on the mitochondrial haplotype that you carry, some mitochondria are more or less efficient than others. Like sub-Saharan African L0, the kind of godmother mitochondrial haplotype that is the considered where all the others came from. That was mapped out by this guy, Dr. Douglas Wallace, and his team from the University of Pennsylvania years and years ago. He's an older researcher now, but he's been studying this for decades. They found that basically certain mitochondria are optimized for very, very hot environments. Like, so they produce less heat, so they're more efficient. And kudos here to Dr. Jack Fruce, because he put a lot of these pieces together, and I learned a lot of this from him, as well as to mention the clock versus camera analogy. He put that very nicely. I'm sure he wasn't the first person to come up with it, but anyhow. And so, I like to give credit where credit's due. So to Dr. Douglas Wallace and his research, he would talk about how basically in Africa, you need that extra energy to run away from a lion, for example, right? And so this is why these, for example, African people win marathons consistently. Of course, some Europeans will, but biologically we're disadvantaged. We don't have that capacity that they do for, consistent aerobic respiration as effectively. And they're much more efficient. But Dr. Wallace says in some of his lectures, but if you go north, you're not going to have to run away from lions, but you're going to freeze to death in Northern Europe, So humans being very adaptable, unlike, let's say, lions, like they never made these adaptations. There were saber-toothed tigers, so some of them did make these adaptations. But anyway, humans then in northerly places or far southerly places actually focus on being less efficient in the mitochondria, releasing more energy, which means releasing more energy as heat, which is actually a benefit. So it's actually important. But that's part of why, like, I, and maybe you would too, struggle being in Indonesia or Bali or Costa Rica, because it's hot, really hot, right? Sometimes I literally feel like I'm dying from the heat. If I'm not in AC, I can't think. Like after 95 degrees Fahrenheit or even 90 plus, but with that humidity, it's just like, oh, I can't even think. So yeah, this is kind of how the mitochondrial respiration thing works. To your question was just basically how else is light affecting our system? So, and how is it related to the diet and so on? If we sleep well, again, back to your original point, then mitochondria are going to work better, and we're going to be able to produce energy with less reactive oxygen species and have less of this damage, which ultimately causes aging, this reactive oxygen species damage. So if we can repair more, then every day when reactive oxygen species and oxidative damage is accumulated, which is aging, we can kind of reset the clock a little bit closer to where we started. And then the difference in the damage we accumulate and what we're able to repair while we sleep is aging, the difference each day. And so the goal would be to, maximize the repair and minimize the damage. And proper light hygiene, a healthy light diet can, play a really significant role in this process.